Okay, the effectiveness of a blood pressure drug is being investigated. How do they know if a new drug, how does the FDA, Federal Drug Administration, find out if a drug is working or not? Right now, we're in the COVID days. They're trying out new COVID um, treatments, right? Or new COVID preventative measures. So how are they going to know when they've got it right? Well, they're going to try it on a few people, aren't they? Right? You with me? So an experiment finds that on average, the reduction in systolic blood pressure is 80.5 for a sample of size 28, standard deviation 21.2. Estimate how much the drug will lower a typical patient's systolic blood pressure using a 90% confidence level. Assume the data is normally distributed. Enter your answers. All right, so what are we talking about? Again, I want this to be real. This is no good if it doesn't help you in the real world. Not that you're going to do these things. You probably will never actually, you might, but you'll read them for sure. In the professional world, you will read, just not even just in listening to the news, you will read and hear about statistical data, studies, and we want to understand what they mean and how they work. So let's talk about it. How do they find out? Like right now, they're testing for COVID, right? And they want a vaccine for COVID, don't they? Well, how do they know? How do they know once they've got it? They try putting stuff together. Well, they try it out, don't they? They don't just give it to everybody right away. That would be irresponsible. They pick a sample and they give it to 50 people, 100 people, whatever, and they see how it goes. But now you might think, well, yeah, so that's simple. You just give it to some people to see how it goes, and then if it works, you give it to everybody. Well, it's not that simple. Let's be a little more careful about reality. When you say see how it goes, it doesn't always work for everybody. What if it works for 90% of the people? Does that mean it's good? What if it only works for 50% of the people? What about 60, 70? I mean, how much do you need? And then not only that, what about the fact that that might have just been a weird group of people? Isn't that possible? What if you gave it, what if you picked 10, whoops. What if you picked only 10 people? And here, let me erase that. It's kind of getting in the way there. What if you picked only 10 people and you gave them the new COVID vaccine, and 9 of them, let's say 8 of them, when exposed to COVID didn't get it, the other 2 did. So they think, okay, that's pretty good. Is that good? Are we pretty sure? How sure? Can we put a percentage on that? Right? The nation would want to know. People would want to know. We would want statistics to inform us in this situation, wouldn't we? This is right now statistically very important to our nation, more important than the election, I think, which is another very real and current application of statistics. People want to know who's going to win the election. People want to know if a new COVID vaccine, some of the new ones they have in Europe and stuff, are those effective? Will they really work? Well, how do they know? They test it. Well, let me tell you, how do they test it? What if they test it on 10 people and 8 of them get better? Is that good enough? What with oh no, that's not good enough. What if 9? What if 9 out of 10 get better?
No, it's not good enough because 10 people doesn't account for 10 million people.
Yeah, 10 people is not very much, is it? You could easily see, you see what could happen. We all sense it. Let me put it into words what you're all sensing. You're right. You're sensing that, look, you could have just gotten a lucky group of 10 people. Lucky either way. Lucky like maybe they weren't going to get COVID anyway. Maybe they were just 10 people who were naturally very resistant to COVID, and they would have never got it anyway. And the vaccine's actually doing nothing. Maybe that could be right. You could get a random, or at least 9 of them. Maybe 9 of them were just super healthy people, or had just great immune systems, and by random luck, you happen to get 9 people that had super strong immune systems. They weren't going to get COVID anyway, no matter what happened. And it's the vaccine's actually not doing anything for them. Maybe. So that's the problem, isn't it? There's always this random element to life. Right? How do we know we didn't just get a lucky group of 9 out of 10 people? Well, what you should do is take more people, huh? So what if you gave it to 100 people and let's say 95 of them got better. Now that's a little more believable results, isn't it? Now you might say, well, yeah, but maybe you just got a lucky 95 out of 100 people. Well, that's not very likely. Are you feeling it? I'm sure you are. You're feeling that that's almost not possible. It's very unlikely that you're going to get 95 by, you're randomly selecting people, that you're going to get 95 out of 100 just luckily had super strong immune systems and really the vaccine's doing nothing. That's not very likely. But if you're really unsure, you can make it even higher, couldn't you? What if we said, all right, just for the naysayers, we'll go with like 500 people, and maybe I don't know, would that be like 480 of them, got better. So is that pretty good? Yeah, that's pretty good. That's pretty good, right? I mean, you're going to tell me that you think you got a lucky 480 people out of 500? I don't think so. So do you feel that? Do you feel how it's all about probability, isn't it? It's all about ruling out the chance of luck. So that's why we take bigger and bigger samples. But in reality, though, it's not always easy to take bigger samples. Why? Well, because do you want to volunteer for the new vaccine when it's still uncertain? Probably not. So it's not easy to get a lot of volunteers for a new medical treatment of any kind when it's unknown. What they do is make it free at first, and that way they get people to volunteer because they get it for free, but that's a little risky. So anyway, my long story short, they're not always able to get a big group. Sometimes all they can get is 50 people, and maybe 45 of them get better, or resist COVID when exposed. So is that believable? And so that's when statistics comes in as a scientific method to tell us the percentage chance that we've got it right. The percentage confidence level. That's why statistics is important to real life. All right. So with that backdrop, let's run the numbers on this systolic blood pressure drug. So they've got some new drug and they're investigating it, the FDA, the Federal Drug Administration. So the experimenter finds that on average, I'll use my other thing, the reduction in blood pressure is 80.5 for a sample size of 20. So basically this researcher gave it to 28 people, sample size 28, and their blood pressure went down 80.5. That sounds like a lot to me. I don't really know blood pressure numbers, but that sounds like a lot to me, right? Their reduction was 80.5 and the standard deviation was 21.2. That's like, right, how much variance there was. Not everybody went down exactly 80.5. That was the average or the mean. But there was some variation. The average distance from that was above or below by 21.2. That's the standard deviation. Estimate how much the drug will lower a typical patient's systolic blood pressure using a 90% confidence level. Assume the data is normally distributed. Enter your answer. All right, so they want us to say, based on these results, based on this mean, this average, the average person's blood pressure went down 80.5 for a sample in of size 28. They gave it to 28 people and the average person's blood pressure went down 80.5. So can we form a 90% confidence interval? Yes, we can. So here we go. We go to our calculator. We hit stat. We go over to tests. And we go way down to, I think it's number 8, and we find T interval. And hit enter on the T interval. And then we have to go over to stats, not data, stats, and hit enter. Because we're entering statistical information. Okay, then they ask us for X bar. So that's the average, that's the 80.5. and they ask us for, back here, let me just put it right over here. X bar, 80.5, the S sub X, that's the standard deviation, 21.2, the N, the number of people in the study, 28, and the C level, confidence level, we want to be 0.90, 90% confident that we captured the real average. What is this drug really going to do over the next, 50 years that it's used? What's going to be the real average that we know over the next 50 years? What's the truth? That's what we're looking for. So I'm coming on down. I'm going to do the numbers on my calculator. 80.5, 21.2, 28, confidence level 0.90. So I'm getting the answer 73.676. They said 3 decimal places to 87.324. Again, I can show that with my calculator here. So clear this on, clear this. Okay, so we push stat, go over to test, go down to T interval, enter. I'm on stats already, so that's perfect. If I was over here on data, I would have to move over to stats and hit enter. Okay, so go on down. X bar was 80.5. Okay. 80.5. And the S sub X was 21.2. And the number in the study was 28. The confidence level was 0.90. You don't have to put in 0. Calculate. So there it goes. There are the numbers that I mentioned. Back to the iPad. Okay, so there it is. So what does that mean? Let me make sure you're clear, because that's probably the most important thing. In real life, you will likely never calculate these in the real world. You might if you get a stats job of some kind, but probably you'll read studies. So what does this study mean? It means we are 90% confident that the true average reduction, the true average reduction in blood pressure will be somewhere between 73.676 and 87.324. That's what we're saying, somewhere in that interval. We are 90% confident that the real average, right, over the next 20, 30, 40, 50 years when they use this drug, the real result, the real average for everybody who ever uses this drug eventually, the real average, we're 90% sure is going to be somewhere between 73 and 87. That's what a confidence interval does, based upon the survey of 28 people. That's the usefulness, very useful to real life of these kind of studies. But we're not 100% sure. Make sure you understand it's not 100% sure. It could have been a weird group of 28 people, but it's not very likely. It's not very likely. We're 90% sure that it told us a lot of truth and that the real average will be somewhere between 73 and 87.